So welcome to NIS304. My name is Dave DeRico. I'm a networking specialist here in AWS Enterprise Support, and today we're going to talk about integrating Zero Trust into your network architecture. So we'll cover a few things here. First, I'm going to give you an overview of Zero Trust, and then I'll walk through some of the network-centric security controls that we all know and love. And this is going to be very familiar to you, and I did this very intentionally because I want to talk about what we're already doing today so we can think about how we integrate Zero Trust into that. So from there, we'll look at implementation and migration patterns for Zero Trust, starting with client to service with verified access, and then going with service to service with VPC Lattice. And then along the way and at the end, we'll summarize with some best practices and considerations. So the obvious question is, what is Zero Trust? There's a definition on the screen here. I'm not going to read it word for word, but essentially, the idea comes down to Zero Trust is not a specific architecture. It's not a specific service. It's a set of mechanisms that allows you to go beyond network-centric controls to integrate other sources of information as well. So we have this notion of identity-centric and network-centric controls, and we want to use them in a complementary fashion together. Now, from network-centric controls, this is what we all know and love, right? We've got a VPC, we've got security groups on our resources, and we've got network ACLs on a subnet level. Now, these are somewhat different. Security groups are stateful, network ACLs are stateless, but fundamentally, these are both going to rely on the same kind of information. They're going to rely on a source IP or CIDR block, a destination IP or CIDR block, protocol port, and then some kind of action, whether that's an explicit action like you do in a network ACL, or an implicit action like you do in a security group where that's an allow. Now, this all makes sense. We've been dealing with this for quite a while, but this is just within the scope of a VPC. Most of the time, we're not operating a single VPC. We have multiple VPCs, and they all need to have some form of connectivity between each other. So we'll do something like have our data center here too, and we need to integrate that in. So we'll put in something like a transit gateway, and then add in direct connect for that. So our traffic between VPCs goes via the transit gateway, as well as to on-premises. Now for clients who are outside of that, we could connect via a third-party VPN, again via direct connect, or we can go directly to a public-facing workload, like our public-facing ALB. Now, at this point, we might decide we want to implement a firewall as well. So we'll create an inspection VPC, like the one that's on the screen here, and we'll deploy a firewall inline, and we'll route all our traffic through it. Now, I want to pause here and make a distinction between two different use cases that we typically see people using firewalls for. The first is just straight access control, and you can think of this as your firewall acting like a souped-up network ACL that's just centralized in one place, where you're just doing straight access control. You're allowing and blocking traffic purely based on network CIDRs. Now, you might also be using this, since this is your centralized point, for logging and visibility. Makes sense. All of your traffic goes through here. It's a good place to look at it. And so for access control, we're going to, again, rely on the same kind of information we saw with security groups. Again, source IP, destination IP, port, protocol, and some kind of action. So that's access control. Now, I want to make the distinction again between that and what I would think of as inspection. And that's where you're doing things like deep packet inspection, where you break apart a packet, reassemble it, you've done your inspection, and then you send it along its way. There's a distinction here, and we'll come back to this further in. And this will also include things like data loss prevention, or if you have mandates where you need to have that in place. So we'll insert that into our architecture. So now traffic between our VPCs goes through our firewall, as well as to on-premises, and we can even do things like centralize our egress. But now we've introduced some operational challenges. So if this app team wants to talk to this database, well, now that has to go through a firewall, which means we now have to involve our firewall administrator. How many of you are firewall administrators or manage firewall rules? None of you. Lucky. Okay. So what that means is if you've never been in that position is that as the firewall administrator, you now have to arbitrate every request that goes through a VPC, and you have to decide, is this allowed, is this not allowed, and we add operational overhead. Now in this case, we'll say, okay, sure, that's allowed, so we'll let that through. Now that's for between VPCs and on-premises as well, but we'll want to make some changes to our remote access. So we'll add something like a VPN. Now I'm going to use client VPN in my examples today, but you can use another VPN. It'll probably work in a similar way. So this is going to introduce us to the idea of authentication. And this is kind of the first time we're going to be really talking about identity. And so we can authenticate against Active Directory or SAML, as well as using certificate-based authentication. And that'll be subject to a session timeout. So I authenticate once, and then I don't have to do it again until that session timeout occurs. This is also where we'll bring in the idea of authorization. and authorization being, in this case, if I'm a member of a particular group, I can access a given network CIDR. So we can do that on a VPN. We've got some other controls here as well, like client route enforcement to prevent us from leaking our routes out locally. We can also do this on an ALB. We can implement authentication there. So when our client tries to connect, if it doesn't have the right session cookie, it'll go through that authentication process. But this is also still subject to that idea of a session timeout, right? I authenticate once, and I don't have to do it again until that session timeout occurs. So we'll add this in. Now our clients can either connect directly to the ALB and authenticate there, or they can go via the VPN, optionally passing through our firewall, etc. So how many of you recognize this architecture? Show of hands, real quick. Okay, how many of you have this architecture? Okay, about the same number of people. So we're all starting from the same place. This is going to be our starting point today. Because from here, we realize that we're working with just network-centric controls. They're operating at a network perimeter, and that can be at the VPC edge, that can be at the internet edge, etc. Our access is based on network CIDRs because, for the most part, my IP address is my identity. We're evaluating access once through authentication until that session timeout occurs. From a flow perspective, we only are going to get visibility at the flow level. We don't have visibility into what's happening at the application layer a lot of times. And finally, there's that operational overhead I mentioned earlier where, as a firewall administrator, you now have to be responsible for making sure that everything that goes through is actually allowed. So thinking back to this, how can we actually use identity here? And what does identity mean? So let me give you an example. Security group referencing. Security group A allows traffic from B, and vice versa. Now, on the surface, this doesn't look too different from what we had before, except now group membership becomes a relevant property in determining whether or not you can actually allow a particular flow. So I'll create these rules, and as I add resources, or as I delete resources, I don't have to do anything else because the group membership is what's important here. Now, this isn't a single VPC, but I can also do this across VPCs. So I can do this via a VPC peering connection, as well as via either a transit gateway or, as of last week, Cloud WAN as well. Come back. Now, with this, there are a couple of considerations. You won't be able to do this if you have a firewall in the path between VPC A and B and your transit gateway and your Cloud WAN. But this is still closer to what we want. This is zero trust adjacent because, again, we're using our security group membership as a form of identity. So ultimately, we want to be able to operate at the network and application perimeter. We want our access to be based not just on network, but also identity. We want logging and visibility of our application requests. We want to continuously evaluate access in real time instead of just authenticating once. And we want to reduce that operational overhead wherever possible so we can set the broad boundaries, and then if our application teams need to have more specific controls, they can put those into place. Now, there's a lot of zero trust use cases. We could be talking all day about every single one of these use cases. Now, as I mentioned earlier, today, we're just going to focus on two. Our goal by the end of this session is we're going to have well-architected a zero trust model that focuses on these two services, and we'll integrate them into that architecture we've already looked at. We'll start with client to service with verified access, and then we'll move to service with VPC lattice. So with verified access, we'll start off here. This will provide us secure access to our applications without requiring the use of a VPN. So to do that, we'll get a couple of things here. We'll evaluate each request in real time instead of just authenticating once like we saw before with a VPN or an ALB. We'll be able to log all of our access attempts, whether they're allowed, whether they're not allowed, and we'll have visibility into why they are allowed or not allowed specifically. And if we're using existing identity or device trust providers, we can integrate that in with verified access. So let's walk through how this works. So I'll start with a simple example here. The first thing we would need to do is create a verified access instance. And you can think of an instance as a container that organizes all of the various verified access components. It's also where we'll configure logging, as well as configure an integration with WAF as well. We'll have different trust providers here. Now, we can have identity trust providers and device trust providers. Now, with identity, that can include things like OpenID Connect, as well as IAM Identity Center, back up here, as well as device trust providers like, if you're using a device management solution like Jamf or CrowdStrike or something like that. Now, the number and type of trust providers you use will influence how many verified access instances you have. I'm only using one here But if you need to have multiple identity providers, you would need to have separate instances for those. Every instance will have a single identity provider, but you can have additional device providers as well. Now, with the trust providers configured, we can move on to setting up groups and policies. Now, groups are essentially exactly what you would think they are. They're applications where we've grouped them together based on a common security need. So all applications in that group will share a group policy. And our apps can also have an app level policy. So we really have this idea of two different this is ridiculous. So we have this idea of broader policies at the group level, and then at the application level or at the endpoint level, and I'll talk about endpoints in a moment, we have more specific or more granular policies there as well. Now, about these policies, you can think of these policies, they're written in a language called CEDAR, and this is a policy-based language that allows you to do things like express fine-grained permissions as easy to understand policies in your application. And this will be how we define the rules for accessing our applications. And so I've got an example policy on the screen here. I've got my effect, my scope, my condition clause, and this information will be evaluated against my trust data. So let me give you an example of how this works. So my trust data will come from my providers, and I'll evaluate this against my policy. So here, I've got an AVA policy, and this can be attached either to my instance or to the application. And now I've got an example trust claim that's being sent to AVA, and this will include identity information as well as information from my device providers. So now, I've got this information, and AVA is going to go through and evaluate this claim against the policy that I've set up here. Now, I'm not going to go through it line by line, but you can see as we go through, every line is going to be evaluated against the information that was provided in our trust claim. And if it's all good, AVA allows the traffic to pass through. In this case, the claim meets the policy requirements, so we're good to go. Now, take a quick moment and notice this. There's nothing in here that involves IP addresses or ports or protocols. We don't need that. We can certainly add that into our policies. That is something we could include if we wanted to, but it's not a requirement here. We've moved beyond that, so now we're using identity as well as device posture as our main evaluation criteria for whether or not we're allowing something through. So, with these groups and policies defined, we can now go ahead and create endpoints. Now, I'm using ALB as an example on the screen here, but we can have multiple different endpoint types. We can use an ALB, a network load balancer, an elastic network interface, as well as either a network CIDR or an Amazon RDS instance. Now, these endpoints will support different protocols. So if I'm going to do HTTP, HTTPS, I'll need to have a domain name, and if I'm doing HTTPS, that will require an SSL certificate as well. But I can do that on those top three, the two load balancers in my network interface. If I want to just use TCP, though, I can do that across any of them, and that'll be supported on all endpoint types. Now, this is a good point to stop and think about how this would work from a multi-account perspective as well, because a lot of times we're working in a multi-account environment. Stop that. So from a multi-account perspective, I can create my groups and my policy, and I can share those groups and policies out using Resource Access Manager to my Spoke accounts. And then from there, I can use those groups and policies to create the individual endpoints and apply those policies at the endpoint level as well. So at this point, I've set up a lot of stuff inside the cloud, but I also need to configure my clients. So if I'm going to use device trust context here, I'll need to have a browser plugin, and that could be a browser plugin that we provide or one that comes from whoever your device trust provider is. Additionally, if you're going to connect to TCP resources like the ones I just showed you earlier, you will need to have the connectivity client installed there as well, because the connectivity client is going to install and configure that secure tunnel and ensure that that user auth is continuously performed like we were talking about earlier. And the last note here would just be we need to update our DNS. So for my HTTPS app 1, I'm going to create a CNAME record to my verified access endpoint, and that's an FQDN that AVA generates for me automatically. And I'll just CNAME that. And as long as I set up my domain previously, again, if this is an HTTP service, I'm good to go and I can connect. Now, from a flow perspective, first my client will connect to AVA, and then I will use the data from my trust providers, whether those, again, are identity or device, and I'll add that to the context that will be passed into verified access. And I'll also, again, if I have a WAF configured, evaluate that against a WAF policy as well. Now, a quick call out here. Where WAF is evaluated or where that WAF evaluation occurs will depend on, whether or not I'm using IAM Identity Center. If that happens, then WAF will inspect before authentication. If I'm using something like OIDC, that'll happen after authentication. So just keep that in mind. Now we also need to think about the network level, because we still have our security groups here in play. When I created my verified access endpoint, that creates a network interface in the VPC. And so that network interface will have a security group associated with it. So we can allow inbound and outbound traffic from that security group, as well as to our ALB. We can allow inbound traffic from that verified access endpoint security group. Again, we're going to use referencing here. So we'll authenticate successfully. The verified access sends the signed user's claims. But now I'm going to use that against my policy. So I evaluate my policy at the group level, as well as at the endpoint level. And only if both policies are evaluated will this actually complete successfully. Now, from a logging and visibility perspective, verified access will provide us with access logs, detailed access logs like the ones you see on the screen here. And this will include identity details, which include our allowed denied decisions, as well as the HTTP data that we're using as part of this request. And we can even include things like the full trust context in our logs. So if we want to see all of the data that's being provided from our trust providers in the logs, we can do that. And the nice thing about that is we can use these to build our auth policies. So remember at the beginning I showed an architecture. Let's see what that looks like now. So I've added verified access. And it's important to note this just affects one application. That's my path for this particular application here. But everything else still requires the VPN. The rest of my traffic flows are not going to be affected as well. Now I could stop here, but what about my other workloads? Let's take a look at those as well. So first we have a public-facing load balancer that's reachable today through the internet. Well, the first thing we're going to run into is that for verified access to work with this, we need to have this be a private load balancer. So from there, we'll need to create a private load balancer and add that into our design here, add that into our architecture. Now, as before, we'll go ahead and create our groups and policies. We can also share them out. Remember, if this is a multi-account approach. We'll create our endpoints and policies. And remember, we have those policies both at the group level as well as at the endpoint level. And if we're going to set up an HTTP or HTTPS service, we'll need to specify the domain name on that endpoint. And then we'll update the DNS record for my HTTPS app 1 with a CNAME to the verified access endpoint. Now, at this point, we can optionally even just remove that public load balancer, which will leave verified access as the only public-facing path to access this application. Now, let's talk about network CIDR and RDS endpoints, too. I've deliberately saved these for last for two reasons. One, they're TCP resources, but two, they have a lot of similarities in setup, so that's why we're just kind of talking about them together. So the first step, similar to any other resource, we create our groups and policies. We can optionally share them out. Now, for a network CIDR, what I would need to do is I can configure a custom subdomain. And when I do that, I'm essentially delegating a subdomain for Ava to manage on my behalf. And I'll show you why that's important in a moment. So here I'm going to use ava.example.com. Now we'll go and create our endpoints and policies. As we're creating the endpoints and policies, we can configure an endpoint domain prefix. And this is an optional thing, but what we can do is this will essentially be a custom identifier that verified access will prepend to the DNS name generated for the endpoint. So for an RDS database, I might choose something like my RDSDB. And for a TCP app, I will creatively call it my TCP app. So we've got that. Let's start by looking at our TCP workload. So remember that endpoint domain prefix and the custom subdomain? Well, Ava will use those to generate unique FQDNs per resource, which we can then use to access our resources. So if I want to SSH into those instances, I can do so using that FQDN. So as resources are added, new domain names are added, and as resources are removed, they'll be deleted. And that's how I will access these resources in a network CIDR range. So it'll scale up and add those FQDNs for me, and then bring them back down as it needs to. I don't need to manage that individually. Now for an RDS, the endpoint domain prefix we specified will be prepended to the DNS name that verified access generates for the endpoint. And again, I can use that FQDN to access my RDS database using the same tools I would as if I were on a VPN. Now you might be thinking at this point, okay, that's cool, but how do I migrate to this? I've got a VPN today. How do I move to this? So the good news is that you can use both of these together, and the way we'll do this is all about DNS. So to start, let's take a quick moment and look at how a VPN works by itself. So with client VPN at least, and yours might be similar if you're using something different, you specify a DNS server that your clients should use when connected. And this could be something like a Route 53 resolver endpoint, and then you'll have a private hosted zone associated with that VPC where the endpoint lives, and that's how your DNS resolution will work. So when I go to query appa.example.com, that will go to here, my private hosted zone for resolution, and then my traffic will pass through, in this case, to an ALB private IP via my VPN into my transit gateway, my firewall, etc. So this is private DNS. Now, I could also not specify a DNS server. And if I do that, then I will use whatever my local public DNS resolver is. So in this case, I'll query appa again. I'll go to a public hosted zone that has the records for example.com here. Once again, my traffic will go through over my VPN. So let's go ahead and add verified access. Now, if I'm going to do this, there's two things we need to keep in mind first. One is, if you're going to use verified access alongside VPN, you need to configure split tunnel. And the reason for that is you want to avoid the situation where traffic to verified access is traversing your VPN, going out whatever egress path you have, and then looping back around to get to verified access. That kind of defeats the point. The other thing we're going to do is, again, remember that if you're going to use device data, you'll need the browser plugin. If you're going to connect to TCP resources, you'll need the connectivity client as well. So let's start by onboarding a new app. We'll call it app-C. So if we're going to use private DNS, we'll need to add an entry for app-c.example.com here with a CNAME to the AVA endpoint. So when my client is connected to the VPN, they'll use that same process as before to resolve that DNS name. And now my traffic will pass over verified access. Again, because we have split tunnel enabled, we can take separate paths there, even though I'm still using my VPN for DNS. Now, when I'm off the VPN, or if I don't have a DNS server configured, we'll still use the public hosted zone, but again, we'll need a public hosted zone here with that same CNAME entry pointing to the AVA endpoint. The client will use that resolver to resolve app-C, which will point to the AVA endpoint, at which point we're connected to app-C. Now, the thing to keep in mind is that none of these approaches are going to change app-A or app-B. They still require VPN. We've only changed app-C. Let's go ahead and change that. So let's say we want to migrate app-A. Now, assuming we have everything else in place, again, this is just a DNS update. We're changing appa.example.com. We're changing appa.example.com to point to our verified access endpoint. And so now we'll use that to point to our app-A. And similarly, when we're off the VPN, or if we're using just public DNS, we'll have to have the same thing. A record in our public hosted zone for appa.example.com pointing to that AVA endpoint. So we'll go to query appa.example.com, and now we'll use that to access both app-A and app-C. And we can repeat this process as many times as we need until we're just eventually using verified access. So let's go back to this architecture. At this point, our migration is complete. And we can still keep our VPN alongside for any workloads or clients that might still need it. Or we can get rid of client VPN altogether if there's no longer a use case for it. So we've successfully implemented zero trust for our remote access requirements, but everything else, all of our other flows remain unchanged. And we can do this in an incremental process. It's not all one or all the other. So just to summarize what we've learned here. So first, remember that if you're going to have multiple trust providers, if you need separate identity providers for those, that's going to be separate instances. If it's all the same identity provider, you can use the same instance. Remember, you can group endpoints with common security requirements into common groups. And then you also have the flexibility to apply policies both at the group level and at the application level. If you're going to use this alongside verified access and VPN together, you need to make sure you're enabling split tunnel on the VPN. And finally, remember that this might not be the right fit for every workload, right? I mentioned TCP and things like that. If you have something that requires UDP, it might not make sense to migrate that app. It might not be supported with verified access, in which case, maintain the VPN for workloads that need it. So, that was client to service. Let's shift gears and talk about service to service with VPC Lattice. So with VPC Lattice, this allows us to take those same zero trust concepts that we just illustrated with verified access, and now we're going to map some of those to service networking as well, or east-west networking if we're thinking about it from a VPC perspective. So we can do this with a couple of ways. First, Lattice is going to give us access controls through auth policies. It'll work across multiple different compute types, like you can see on the screen, as well as TCP resources, again, similar to verified access. For layer 7 services, we'll have the ability to do some advanced routing controls similar to what we do with an ALB. So, things like load balancing, routing, weighted targets, et cetera. And finally, from a logging and visibility perspective, again, we'll also have access logs, which will give us that visibility that we want to see. So as before, we're going to take a look at each of these components in turn and see how they all fit together. So first, we have a Lattice service network, and that service network is, as the name implies, going to be the construct that allows us to communicate between services and resources. We'll configure access logging on here, and we'll talk more about that in a little bit. Now, typically, I'll only have a single service network, but I could also have multiple service networks. And there are some use cases for that, which we'll discuss more in a little bit when we talk about how we actually connect this all together. Now, one call out here as we're going through this, I've grouped these into a providers on one side and consumers on the other. So with that, this is kind of implying a binary here. I've made this choice very deliberately because I want to illustrate the different flows, but know as we're going through here that a VPC can be both a provider and a consumer of services and resources. I'm just separating them out for the ease of visibility here. Now I keep talking about services and resources. What are those? Let's start with services. So a service is essentially going to operate like a layer 7 proxy. And you can think of that just as running in front of your different compute, whether that's running on instances, containers, serverless compute. And that'll consist of listeners. I've got an HTTPS listener here. You could also do HTTP. You could do TLS pass-through, rules, and then target groups, where we can do things like weighted routing, et cetera. Now, if you're thinking, this looks a lot like an ALB, well, yes, it is. These are going to operate exactly the same way as an ALB does, where instead, Lattice is now providing that proxy and load balancing functionality instead. And what this means is we can set our targets directly on the compute, or we could use an ALB instead if we just want to shift it to the ALB. So we have some flexibility here. So for my case, I'm going to go ahead and just kind of bypass the ALB, and I'll make these, these compute services my service here. So I need to make them accessible to the service network, so I'll create a service association. And now that'll be accessible. But, slight problem, I've got this database. And this database is not going to operate on HTTP, HTTPS. Because remember, these services are operating at layer 7. So for this, I'm going to need a different construct. And that'll be a VPC resource. So resources operate at layer 4. There's no proxying involved. Instead, we're using essentially managed NAT and port forwarding via Lattice to pass traffic through Lattice. And to define our resources, we'll need a resource gateway, and we'll create a security group and associate it with that. And this will be in the VPC that has the resources that we want to make accessible through our service network. So we'll have an identifier, which will be either a publicly resolvable DNS name, a private IP address, or an ARN. And today we support accessing an RDS instance or cluster through an ARN. We've got our protocol, our port, and then we're good to go. We can specify any of these ports here accessible via TCP. Now we can also define these as either a single configuration or as a group configuration with child resources. And a common example of this would be something like an RDS cluster, where we've got maybe multiple readers and a writer node. This would be set up as a group resource configuration that we can then access. Now this is also a good segue to how we talk about cross accounts. So there's two kind of approaches here that you can think about. The first is going to be a shared service network, and this will be probably similar to what you're doing today if you've got like a transit gateway or a Cloud WAN core network, where you've got a networking account that has your constructs, and then you've got all your spoke accounts. So we'll do something similar here, where we've got a Lattice service network, and there are services and resources on the side. And we'll use RAM, Resource Access Manager, to share out the service network to those accounts and then to do the associations there. That's one approach. Now the other approach is where we go in the opposite direction. So again, same constructs. We have our service network, our services and resources in the spoke accounts. But here, we can use Resource Access Manager in the spoke accounts and share those into an account that has the service network and do the association there. So functionally what that means is we can take either that centralized approach or a more distributed approach, and if we want to have multiple service networks, this allows us the flexibility to do that because we can associate our services and resources with multiple service networks. So moving right along, we'll add our resource gateway and our resource configuration to the architecture, and we'll associate that with the service network, so now that will be discoverable just like our service was. So now we need to think about how are we actually going to control access to these. Now for services, I want to start with services in particular because this gives us the ability to use something called auth policies. Now auth policies are essentially IAM policy documents that will attach to either the service network or the service itself. So here I've got, back up, here we've got our service network with a broad policy applied to it. And generally speaking, we're going to apply broad policies at the service network because this is going to encompass everything that traverses through the service network. So in the example you can see on the screen here, the criteria is if I'm a member of this organization, I can access this service network. Again, deliberately very broad. We're setting the outer boundaries of what we want to be considered acceptable. Now at the service level, this is where I can be much more granular. I can do things, for example, like saying like, in this policy, I only am going to allow this particular caller access to this particular service if they're performing a GET. If I try to do a post or a put, that won't be allowed. Now, in order to ensure that I can do this kind of stuff, where I'm adding this identity information in, I'm relying on caller identities, I need to sign any requests that go into Lattice with SIG-v4. Now, if you're not familiar with SIG-v4, this is a super high-level overview. There's a lot of resources that talk about it in more depth, but essentially, this is a protocol we'll use for authenticating requests into AWS services, and in this case, Lattice in particular. Now, what this will allow us to do is verify identity using a signature that we create from our valid AWS access keys. So the secret key ID, the access key ID, all of that stuff that you would use for using the CLI or something like that, those credentials will be used, and we'll calculate a request signature using that, which will protect our data in transit. So we have to make sure that that data has not been tampered with. And we'll also have a 15-minute window to prevent against replay attacks when we're using SIG-v4. And our keys that we're using at the very beginning to start this whole process are continuously validated. So that's how we're getting that continuous authentication that we were trying to get to earlier. Now, if we want to do something like that with this, we will require authentication here because in this case, this particular policy, we won't have that org ID information unless we're using SIG-v4. Alternatively, we could allow anonymous or unauthenticated requests like so, and we can define that at the service network level, whether we're saying we want AWS IAM to be required or we want to have anonymous requests allowed as well. So at this point, we've got everything built. How do our VPCs actually connect to this? Well, we've got two options here. The first option is called a service network association, and this will behave similarly to if you have something like a S3 gateway endpoint or a virtual private gateway associated with your VPC. It's essentially a local association to your VPC. It'll have a unique host name per service and per resource defined there. And then we'll have IP addresses when we go to resolve the DNS names that are coming from these services, because Lattice will give us DNS names for each service and resource that we have. Those IP addresses will resolve to IPs from the Lattice prefix lists for both services and resources. So to give you an example, I've got service IPs. Those will come from that 169.254.171 address range. And then for resource IPs, these will come, again, from another non-routable space, 129.224/17. So when I go to resolve DNS, and these are part of a managed prefix list I should call out as well, that you can use in security groups if you're doing things like security group referencing. So in this case, if my client VPC goes to resolve the myService FQDN generated by Lattice, that'll resolve to a non-routable 169.254 address. And this is similar if you've ever used like the EC2 instance metadata or the NTP server. It's using that same construct there. Similarly for resources, this will resolve to a unique IP address per resource. So here I've got a 129.224 address, and that will be unique per resource that I have in my service network. So this is an association. Our second option is going to be a service network endpoint. Now, these will operate like private link endpoints, and they'll consume IP addresses within the VPC. And this will be available for the entirety of the service network. It's not a one-to-one mapping of an endpoint to a particular resource. So each service and resource will have a unique host name, an IP address, and those IP addresses will now come from the client VPC. Again, similar to what you would have with a private link endpoint. So if I do have this in client VPC at the bottom there, that CIDR block is 10.2. So when I go to resolve my VPC, or my DNS, excuse me, for the service, I'll see it comes to an address from that VPC, and same for that resource as well. Now there is a third option here, which I'm not going to talk about in great depth, where if you essentially want to bypass Lattice altogether and just have resources be available in a one-to-one mapping, more similar to what you would have with private link, that is an option. I'm not going to talk about it in depth today, but if you want to know more about that, we had a great reInvent session this past year that talks more about that in depth. So if you're curious about that, I would encourage you to check that out. And then we'll go ahead and move on. So at this point, we have these two options. Which one do you choose? There's some specific use cases where you would want to use endpoints instead of the service network association. Because with the service network association, I can only have one per VPC. So if I needed to access multiple service networks, I won't be able to do that with the service network association. Now, I mentioned this earlier. Why would you want to have multiple service networks associated with a VPC? Well, you could have a scenario like if you're connecting to multiple third parties via Lattice. And they have separate service networks, but you need to consume them all from a single VPC. So instead, what we can do is we could have a service network endpoint alongside our service network association, and we can access multiple service networks that way. Alternatively, we could take a different approach where we have multiple service network endpoints in a single VPC, and we're using DNS to connect into those separate service networks. Another common scenario that you might think about here would be a shared services approach, where if you need to have a VPC that's reaching out to multiple different environments, like let's say you have a service network for dev, for QA, for prod, you can do this here with multiple service network endpoints. Now, another use case would be connectivity from on-premises. So remember that these were non-routable address spaces, but if we have connectivity from on-premises via our transit VIF or via a private VIF or maybe a site-to-site VPN, we can now reach service network endpoints because those will use IP addresses that are routable within the VPC instead of that non-routable space we saw before. So we could even throw a firewall endpoint in there if we're using a private VIF and a VPN connection to a virtual private gateway. And if we want to sign our requests from on-premises, we could use IAM roles anywhere to ensure that we're doing that SIG-v4 signing as well. And when we go to resolve DNS, that will now resolve to those routable IPs, which will be reachable over our hybrid connectivity, both for services as well as resources. And again, this is a single service network, but the same principle is going to apply with multiple service networks as well. If we wanted to access all of these from on-premises, we could do that with multiple endpoints in that VPC. Now, the other consideration here would be cross-region access to Lattice services. Now, in this case, I've got a client VPC in region A, and I've got a service network in region B, and I want to access some stuff over there. So what I will do is I'll create a service network endpoint, and I'll need to have some kind of existing connectivity between region A and region B, and that could be a cross-region peering connection, that could be transit gateways peered together, that could be a Cloud WAN core network. Regardless, that'll be how my VPC can now connect to that endpoint. But this still requires us to have full layer 3.4 connectivity to that remote region. So alternatively, I could do this via service networks instead. So in region A, I've got the same setup here, but in region A, I've now created an association from this VPC into a service network. And in region B, I'll have my service network endpoint, same as before. But region A, I'll now create a resource gateway. And I'll create a configuration associated with that, and I'll target the DNS name of that endpoint in the remote region. So now I'll still need to have some kind of connectivity between my regions, again, peering, transit gateway, Cloud WAN, etc. But I don't have to have all of my VPCs in region A with that full connectivity here. If I just want to do this via service networks, this essentially gives me a way to bridge these regional constructs together today for service networks. So just to summarize here, If you're going to do service network associations, those are going to be probably kind of what you'll start with, and they'll be for a single service network per VPC, and if you don't have any concerns with IP consumption. But if you need to access multiple service networks or access them from on-premises or outside of a given VPC, that's where you would want to use a service network endpoint. So we looked at something similar with verified access. What does the flow look like here? How do we think about this from a defensive perspective? Well, the first consideration for security is, if there's no service network endpoint or no service network association, so I'll set them up here, but if I backtrack, neither of these VPCs can access my service network. So automatically I have this connectivity aspect that if they're not attached to the service network, they won't be able to consume anything in that service network. So I'll add them back in. But we also have security groups. Each of these is going to have a security group that we can associate with it. And we can restrict the traffic allowed into our service network with these security groups. And we could even use security group referencing to scope that down even further. So in this example, my client security group is the only resource that's going to be allowed to send traffic into my service network. And again, I can do that on either of these security groups, regardless of which connectivity method I'm choosing here. Now, if I'm accessing services, on the provider side, I'll have to allow inbound traffic from those VPC lattice prefixes. I'll connect here. Now I need to think about my auth policies as well, because remember, for services, we have our auth policies too. So our auth policy will be evaluated at the service network level, as well as at the individual service level. And only if both of those are allowed through will I pass my traffic through. In this case, I'm actually targeting an ALB, not the compute, because remember, you can do both, and pass that through here. Now, for VPC resources, this is going to be a little bit different, because remember, our auth policies are not going to be evaluated for TCP/VPC resources. So we'll still have our security groups on the client side, and on the provider side, we'll need to allow outbound traffic from our resource gateway to our resources. And in this case, my target security group, I'll need to allow inbound traffic. Again, I can use security group referencing to bring traffic in from that resource gateway security group. So we'll pass through again into our service network. We're not evaluating against the auth policies, and we're connecting in that way. So this starts to get a little bit away from that, but we're still zero trust adjacent. We're still using a lot of other constructs here, and we'll still have some additional visibility in the logs that we can use to identify this. Let me show you what I mean. So here I've got my access logs, and this will all be example of information that you can get for a Lattice service. Now notice this is going to include layer 7 information as well. So it'll include things like the request path, the request method, it'll include the service network ARN and the source VPC ID. So we've got a lot of additional metadata beyond just a CIDR block that we would have had previously. And we can use these, just like we did with verified access. We can use the information that's in these access logs to then go back and build our auth policies either at the service level or at the service network level. So again, same concept applies here. And for VPC resources, you'll notice this is a little bit smaller, a little bit less information, but again, we're not operating at layer 7. We're not going to have visibility because this might not be an HTTP HTTPS request. But we still have information like our service network ARN. We can see the VPC endpoint IDs that this path followed, as well as the source VPC ARN, as well as things like ports, protocols, etc. Now at this point, we're not going through our firewall. So how do we think about that? How do we reason about moving to Lattice when we're coming away from a firewall, and the firewall was previously that point at which we allowed or blocked traffic? How do these constructs map to each other? Well, there's a couple of things here. So remember, 45 minutes ago at this point, I mentioned that there was a distinction between access control and inspection. And that really comes down to what is your firewall doing, right? If you're just doing access control, well, we've seen that we have auth policies for services. We can have those additional security groups in place. We have the VPC associations and endpoints that will control access to those service networks, and we can even break out into multiple service networks. So if you're just doing access control, Lattice can still fit in there. If you're doing something like inspection, though, like where, again, you need that deep packet inspection, you're breaking apart TLS, you're inspecting it there, then Lattice might not be the right fit, and that's fine. Now, from a logging and visibility perspective, we just saw we'll get a lot of that same information from our access logs, as well as some additional metadata that we can use. Now, the second question we want to ask here is, what are our connectivity requirements? Because if we think about our transit gateway or Cloud WAN architecture, we previously had full layer 3/4 connectivity, And then we had to use our firewall to scope that down even further. We had wide open pipes and we had to constrain them. But now, we have to think about, is this a bidirectional process? Or do I need to take a provider-consumer approach instead? I might have some VPCs that are providing services and resources, but don't need to talk to anything else. I might have consumers that don't need to host any services. I can move away from this, bidirectional process and think about it from more of a, what are my actual connectivity requirements? And finally, I do need to go through the task of thinking about what my firewall rules mean. So I've got a firewall rule here, super simple. What do these CIDRs represent? Are they applications? Are they teams? Are they business units? I need to understand what this actually means and translate from CIDR block into human and identity so again, I can map these to auth policies, to service networks, etc. So just to summarize here, when you're thinking about this, first remember that you can manage network associations and endpoints, and that will control access to your service networks. Second, remember that you can associate your services and resources to one or more service networks if they need to be accessed through those different networks. Apply your auth policies for services, and to do that, you'll need to set the auth type to AWS IAM, like we saw earlier, and then you can use the appropriate condition keys in those policies. So that could be the source VPC owner account, something very broad at the service network layer, and more granular at the individual service or application level. And finally, for visibility, that's where access logs, as well as things like CloudWatch metrics, will come into play. So again, how do we migrate? Anyone want to take a guess? I'll give you a hint. It's all about DNS once again. So here, until we configure DNS, our flows are still going to pass through the transit gateway and the firewall. So if I've got public DNS here and I'm using public DNS to resolve things like my AOB, I'll query app.a.example.com. Those will all still flow through my firewall, through my transit gateway, because I haven't changed anything. DNS is still controlling which path I take. Now this is public DNS, where I'm querying a public hosted zone. The traffic flows to an AOB. Same thing is going to apply with a private zone. And with private DNS, I'll have a private hosted zone associated with those VPCs, and they'll use that to resolve DNS and pass traffic to, again, those private AOB addresses. Now my goal here is I want to migrate client VPC B to VPC Lattice. And there's two ways we can do this. Per VPC per domain or per VPC per service. One of these is more granular than the other, so let's walk through them. So the first thing I'm going to do is if I'm using public DNS, if I have a public hosted zone for example.com, and that's how I'm doing DNS today, I'm going to create a new private hosted zone for example.com, and then I'll replicate the records for that public zone into the private zone. Now functionally, this is going to give us a split view of DNS, but this is important to have here because we need to avoid impacting the VPCs that we don't want to migrate. We only want to focus on individual VPCs here. So once I do that, in my private hosted zone, I'm going to update that resource record for app.a.example.com to point to now my VPC Lattice DNS name. Now I still haven't changed anything yet because this zone is not associated, so I can pre-stage as much of this as I want in advance. And as someone who has suffered through migrations before, pre-staging everything as much as you can is super helpful. So I'll stage this in advance, and now I'll associate this new private hosted zone with my client B VPC. So when client B goes to query app.a.example.com, that traffic will now pass through our Lattice service network. Whereas client VPC A is still using that public hosted zone and is not affected. So I have this ability to change this per VPC if I want to do this. So that was public DNS. Private DNS is going to look pretty similarly. In this case, private hosted zone associated with VPCs A and B. I'll create another new private hosted zone, again for example.com. I'll replicate my records. I'll update that resource record just like I did before. And then I'm going to first need to remove the existing private hosted zone association for example.com. And then I'll go ahead and associate that new private hosted zone with client VPC B. So as before, I'll query app.a.example.com. That resolves to Lattice, and that's my path in. And just a quick call out here. I don't know if you all are familiar with Route 53 profiles, but if you're not, if you're going to be managing a lot of private hosted zones at scale, this is a great way to do that and can make your Lattice migration process a lot easier. So that was the first option. Again, there was some variation there depending on which DNS form we were using, but for the second one, it's going to be functionally the same whether we're using public or a private hosted zone, in this case, for example.com. So as before, we'll create a new private hosted zone, and then we'll associate that new private hosted zone with VPCs. But the difference here is that this private hosted zone is for app.a.example.com instead of just example.com, and we were replicating all of those records. We're being much more granular here. So because we've matched this service-specific private hosted zone, once we do that association, Route 53 will now resolve the DNS name for app.a.example.com using that more specific zone. And so that will give us the flexibility that we want. So when we query app A, as before, it's going to go through Lattice. Now this is more granular, and the benefit here is that I don't need to remove that existing private hosted zone for example.com if I'm using private DNS. The downside is that I do need to do this now per service or per resource that I want to migrate to. So there can be some trade-offs here, but you can take either approach. So just to summarize what we've talked about. So first off, remember, when we're thinking about Lattice, we need to consider what our connectivity requirements actually are here. Do these VPCs need access to the service network? If they do, are they providers of resources? Are they consumers of resources? Do we need to have multiple service networks? We've got a lot of options here depending on what we want to do. Now remember, as before, we can apply these coarse-grained service network policies and the narrow service policies. So what that means is, thinking back to our example where we were firewall administrators earlier, now we can set the broad parameters of what's acceptable. And then our application teams or our developers can set more granular permissions based on what they know about the applications. I don't need to know all of that. I've set the broad parameters, and they can be more constrained with what they want to allow in. Use your access logs, and use those access logs to design your auth policies. Remember, use that information and work backwards to build your policies. If you're going to use authentication, if you're going to incorporate some of that identity data, you will need to integrate SIG-v4. And remember, service network endpoints, use them when you need to. Use them when it's appropriate to do so. And remember that Lattice is not going to be a replacement for everything. If you have that requirement for deep packet inspection or some of those more advanced firewall use cases that we alluded to earlier, keep those in place. Nothing wrong with that. You can use these right alongside each other. So at this point, we're using verified access for our remote connectivity into our environment, as well as VPC Lattice for service-to-service communication and east-west traffic. Now, at the same time, we haven't altered our egress flows out to the internet. We still have our traffic passing through to Direct Connect on premises. And similarly, if we have some of those east-west flows that I talked about earlier, where we need to maintain a firewall, those are unchanged as well. We're now complementing our existing security controls with Zero Trust where it can be applied. So, moral of the story, things you should take away from this exercise. First off, Zero Trust is not a zero-sum game, okay? You can use Zero Trust solutions alongside your existing controls. It's not an all-or-nothing approach. And what that means is you can adopt and migrate at your own pace. You can adopt slowly for new services. You could start by migrating an existing one. You could migrate and bring on new ones at the same time. There's a mixed bag here. You can do a lot of different things. You have flexibility with this approach. Remember that you're going to have these two tiers of policy. So think about where you want to delineate those permissions. Who's going to control your central policies? Who's going to control your application policies? Do they need to be closely aligned? Do you even want to have application policies, or do you want to all control at the service network level? You can do that. And finally, maintain your firewalls and VPNs for places where Zero Trust solutions don't fit in there today. You can do that. There's nothing wrong with that. It makes sense to use these alongside each other where you need to. So as you're thinking about a new service, a new resource, bringing something in for remote access, the question you should probably ask yourself is, where can Zero Trust fit in? Is there a spot where Zero Trust will play a role, and should we be looking at that for this? So with that, I want to thank you all for your patience today with the slide mishaps, and thank you so much for joining the session. Please do complete the session survey in the mobile app, and I'll be around for questions right afterwards if anyone wants to chat. Thanks, folks.